Welcome to the course of Microwave Engineering. In today's class, we are going to discuss about classification of microwave tubes. In the previous sessions, we have seen what are microwave tubes and how they are differ from conventional tubes. We have also studied the limitations of conventional tubes. Okay. So in today's class, we will be seeing several classifications of microwave tubes. So how these microwave tubes are classified, what are the subclassifications. The microwave tubes are used as oscillators as well as amplifiers for generation and amplification of the microwave signals with high power. Okay. So here microwave tubes are classified into first one, O-type tubes. Okay. These O-type tubes can also be called as linear beam tubes. Why these are called as linear beam tubes means here whenever we are providing a microwave signal, there exists two kinds of fields. As we all know, these fields are nothing but our electric field as well as magnetic field. Coming to O-type tubes, which are also called as linear beam tubes, electric field and magnetic field are parallel to each other in these kind of tubes where microwave signals are generated. And the next classification of microwave tubes are M-type tubes. First one was the O-type tubes, which are called as linear beam tubes, where electric field and magnetic field are parallel to each other. And coming to the next tubes, they are called as M-type tubes. They are also considered as cross-field tubes. Here, in this case, electric field and the magnetic field are perpendicular to each other. So, we can see the difference of both the tubes, O-type tube and M-type tubes. In O-type tubes are also called as linear beam tubes, where electric and magnetic fields are parallel to each other. Coming to another classification, M-type tubes. M-type tubes are also called as cross-field tubes, where electric field and magnetic field are perpendicular to each other. Okay. Now, these kind of M-type tubes will be coming across in the further units. Right now, this unit is fully related to O-type tubes. How these O-type tubes behaves, how these O-type tube works, and how these O-type tubes produce microwave energy is what all about. Okay. So these O-type tubes are further classified into cavity resonators as well as slow beam structures. Okay. So these O-type tubes are further classified into cavity resonators as well as slow beam structure. Okay. This cavity resonator gives rise to reflex klystron oscillator as well as klystron amplifier. We have two types here. One is an oscillator and one is an amplifier. Both are used for the amplification and generation of a microwave signal, where reflex klystron gives rise to an oscillator which generate microwave signals, and klystron amplifier is used for amplification of the microwave signal. Okay. This gives rise to a cavity resonator where a cavity mechanism, resonator mechanism is evolved. Coming to the slow beam structure, we have forward wave and backward wave. Okay. And coming to the forward wave, we have traveling wave tube. This traveling wave tube can also be called as TWT tube. We will be seeing it in the further classes. What is a TWT tube and how a traveling tube works. Okay. And coming to the backward wave, we have backward wave amplifier, where it is used for an amplification purpose or for strengthening the signal. Okay. So all these O-type tube classifications, we will be seeing it in this particular unit, and the M-type tubes, we will be seeing it in the further units. On the whole, microwave tubes are classified into two types, O-type tubes as well as M-type tubes. O-type tubes are also called as linear beam tubes, where electric field and magnetic field are parallel to each other. Coming to the another classification, it is an M-type tubes, where M-type tubes are also called as cross-field tubes, where electric field as well as magnetic field are perpendicular to each other. These M-type tubes will be discussed later. Okay. Coming to the O-type tube, these O-type tubes are again classified into cavity resonator, which gives rise to reflex klystron oscillator as well as klystron amplifier. And coming to the another classification, it goes to the slow beam structure, which has been again classified into forward wave as well as backward wave. Forward wave gives rise to traveling wave tube, which we can also call it as TWT tube, and the backward wave gives to backward wave amplifier. All these topics will be discussed in this coming classes in this particular unit.